Hello, so this is for my project, and I'm gonna explaining the task one today. So let's go to the task one and start doing our job. So in the task one, we're working on a software that analyzes the Spark player following two areas in the different Spark. So what we have here is we have a list of players. So in the one list there's a basketball players, and the other list we have a football players, and each player has their first name, last name, and a team. And just as I it says, some players play both sports. You want so this is what's gonna do is you want to find the people who appears in the boat list. For example, in the boat and for example, in the boat list we have people called Ajil Huang and Wanda Vokolsky. So now there's the question: how can you find the people who plays both sports? There's the two possible way, and the first way and the slower way. It's a nested list. This means for every basketball players, check every football player, compare the names, and s- so this is slow if the list is the big. So we can do it in our fast way. We like things in a faster way, doesn't it? Like, who doesn't? Okay, first we have to put every single, like all the basketball players in the set. What is set? Set is like a magic box that only stores the unique items. It's very fast as a check when it's something happen. For example, let's try to take an example. We have a set that's there's in this A, B, and C. And if you ask, is it B inside? And it's gonna answer yes, it is. And okay, I think just like that for the foot player too, like you make a full name example, Jill Huang, ask the set, does this name exist in the basketball set? If you if it says yes, this player plays both sport, add them in the result set. Like we have the names: the Jill Huang, Janka Barton, Wanda Vakulski, Jill Malani, Luke Watkins. Oh, you know what? Why did I do this? Like, I think I pronounced most of the names wrong, but that's it. Okay, just like that, in the first, uh, and in the set two, if it's Hansel, Hansla, it's not in the set, it's in the da. So in the final answer, what we wanted to get is just the Jill Huang and Vanda Wakolskas. Wakolskas. So now let's go through it. Wait, where is my thingy? Okay, we can put this over here. Does it in the does this? Yeah, I already ran it, so we already know it. But you know what? It's just for the explanation, of course. So now let's talk about the code, if he said so. Okay, so I think I should just decided to show you the progress of it, so we don't really had to like do anything more. I already did the explanation, like the explanation part of it, and the like a first part of my my video. So I think I should just show you. So the first thing is first, I already wrote down the include lines. Okay, so thing is now. So pretty much in this code, you're writing a program that finds players who appears in a both sport, which is basketball and football. And if a player has the same first name and a last name in a both list, the program prints that player's name. Okay, we already put the include lines and the using namespace std. Now, what we need is the player struct. Now, it's like uh, this creates the player type, like so we can store names and like names and the team together. So let's do it. No, let me just take a space because I like to take a lot of space. If you already realized or not, but I do like to take a lot of space. And then we had to do the string first name. Oops, that was necessary space. First name and string last name. And we need string team. And we can actually, I think that was the first part of it. So now we can actually close this one. Go down and do this. I can close it. Now it's to function to find the players who plays in a both sport. Like I find the common player function. I think that's what it says. In this function, the it takes two lists of players. The return list of the names that appears in a both sport. I kind of wanted to keep checking my OBS Studio because the last time when I do it, I did it, but it didn't get saved. So this is me doing the second time. So let me just left a little comment here. Let's just say um, to find the players who plays both sports. So we can start with the vector string find. Let me take find common players on vector player. I don't want to do the automatics because when I do it, sometimes there's like a some things happen that I didn't really realize yet, and I made a lot of mistakes because of that. So I think the most of the part, I'm just not gonna do the recommended the auto thing is, and I'm just gonna do whatever I preferred for this. Actually, never mind. But it's not a soccer; it's a football. It's a football because in the thingy it says, "Oh yeah, it's not a players. It's going to be a player and a football." Set string. It's not a football players' names. I think I'm just gonna do this as a common and the names because the name stores the basketball player's name, no duplications, and the common stores the players who plays the both sports. So in here, it's just going to be uh, s- no, it's going to be a vector Actually, not the vector. Mm, string vector vector string common. Oh, not the players, and it's not going to be a basketball players. It's a set string, just as I said. It's going to be a names like that. Beautiful. Maybe I should also maybe I should make little comment on this one too because it's going to be a pretty important part. So when it stores the names of the basketball players, and on this one, yes. Now, is it still recording? Good, because I really don't want to lose this one because it's pretty important to me and I don't want to do everything over again and again, just like this said. Because, okay, you know what? Let's just stop chatting about it and let's go to the add the basketball players into the our set. Okay, start with the comments, I believe. Okay, you know what? It is easier full. Okay, just do this. Const after basketball. Okay, best player basketball after player basketball string full full name not plus. That was an accident. MP0. No, first name plus the last name. Okay, that's good. That was no names. Insert full name. Dot dot dot. Hmm. Now to check the football players. Football players. For and for Pepe was the name fine. Mm, let's just do this, and we can. Okay, if names find full name, the full name string full name here. Let me just do it. Let me just do this. String full name equal to first name. Last name. Yeah, that's what I wanted. That's good. If full names, okay. If name is the in the set, good. So we can go and set names tick count full name common fish full name boom return to common. Okay, that was the hardest part. I think we did the hard for already. We did the last one is the return to the result, which means the function send back the list of the shared players, which is return common. So now we need a main function, and just we know what main function is. It's just going to be an int main. Boom. Oh, now we need the players' name. The players, basketball players, the Jill Gator Hung, whatever. It's on the name. We don't need the first names and last names and teams like a Gators. We just need their names like a Jill, Huang, and Gators, and that's it. Okay, let me just do this real quick. Yes. Now we had to do it like this, but we had to do it for the Jill, Janko, Wanda, Jill, and the Luke, right? Yeah. Let me bring the names into this side so it can be also shown. The names. Wait. And I think we don't need the first name. Boom. Last names. Yeah. What is going on? Only thing we need is just the names of the players because it can already tell the first and last name and everything that is related to this stuff. You don't need the last name or team. No need for team. All we need is just the names of the players. And we need that. Jill and Luke plays in the Gators. Um, our basketball players. Boom. Now we need the not. We have different football players, I believe. It's it. So we need the names of the players. All of the names, the vector players of the football players, and we also had the basketball players. No, it's going to be easy. No, it's actually just the vector string result. Define the common player, basketball, football. Exactly. Result. return to zero. So now, when in the output, it's, it had to show up the Jill, Huang, and Wanda Mikulski. So let's just run it real quick. Yeah, you have Jill and Wanda. So that was to for define the first task. And hello, so right now I'm starting the task 2 of this project. And in this project, we just kind of need to find the missing number. So let's look at it, our task. So we are writing a function that accepts the area of the distinct integral of 0, 1, 2, 3, and up. I up till 10 and up to n. So, however, the area will be missing one integral and your function is returned to the missing one. So, it's also said using a nested loop approach will take you up to the beyond addition, it's the square. And so my job is to optimize the code so it be runtime up n. So we learned about the big O notation in this class back really back then, and and I think we should just go back and just like remind ourselves what it was. Uh, s- why I'm not sure if I actually need to do it or not, or if I just could explain what what I could do and whatnot. So in the big O notation, the letter N represents the number of the items in the input. So and one common type of a complexity is the uh, O of n squared. Means the program performs an n operation for each of the n items in the input. In other words, I could say it's like the total amount of work row as the n multiplied by n. Like what the square do, it's just like that's like this usually happens when program in a nested loop, just like that. Using a nested loop approach will take a nested loop. It is like the it means one loop is place it inside the another, which is it's gonna take long. It's gonna be uh, just we don't want that down. Okay, like it's okay, like in this the missing number program, and it's like a slow solution will check every possible number from the O to n and search the inside area. And this approach would like it require n- nested loops. Time complexity will like the might for in the small areas become very slow in the large ones, but it doesn't matter this one. And so in specifically in this in this task, my job is to optimize the code so it could be run in the oh and like this is everything. So let's go back. Let's go to my code, I believe. Actually, I think I'm just gonna show it from the GitHub because I already did the task number 2 in here, and I did it already. So let's just. I think I just should go back to there. Okay, the problem of this is you just had to go back to the missing number. If I remember back in the video, I I did like a I think I did like a 30 minutes video about this one, not in the project. Let's go to the models if I could find it. We did it back then though. It's like I explained it the everything in there and no, not there. What is it? It takes so much time, so I kind of just wanted to show the old video that I made it back then. Whereas the area is there, you know what? It doesn't matter. I forgot. Okay. Uh, let's go to the our code. Uh, I think probably I should. I think I actually wanted to do this on the computer because it's not gonna take so long, and I think we can actually run it together. So let me put up something. Okay, so let's get into the second one. I was just taking a little bit a lunch break, so after this, I'm ready and back in the track. The first thing is first, I already did the header files and the namespace. When I start the video, I would always just like to do that. Now we need a function to find a missing number. In this function, it have to be accept the constant reference of the vector integrals r and takes the okay. You know what? Too much talking. Let's just leave some notes with the comment and let's get in. Oops, I think I did too far. Function to find the missing number. Mm, Huh? And find missing number. Const vector int um boom, that's an R and nope. I'm trying to do this and finish it a little bit faster. Okay, this this actually looks okay because in the int expected sum number, like this line that computes the sum of the integral from 0 to n, no, not 0 to big, oh, n, to using a arithmetic series formula. It's like there's something like, let's just say this represents the total sum assuming no numbers are missing. There's going to be an actual calculation in that too. So let's just um let's double check again. The expected sum is that plus 1 divided by the 2 and equals to the sum of the therefore mm, actual sum. It's no, I think I shouldn't. Okay, that was good. Now we need uh the the main function and the area initialization. I think that's the name of it. So which means we need to write down the int main, and of course this, Um, and for the we're gonna. I think I want to do area from 0 to 10, and missing number is 8. Why? Because I like 8. So you just have to put in the vector, um, and equal to exactly, and 8 has to be a missing. Int n is changed 0 to n. We count the missing number, find the missing number, and ending. And what you need is the return turn to 0. That's it. Now we had to, when we run this, the missing number should be 8. The union. I think there's some mistake. Let me double check again and I'll be back. Okay, now it's going to be a missing number is 8. So the whole project, it was, I already copied and pasted in, it's for my task 2. Mm, okay, you're writing a function. That was it. Thank you. Oopsie. So let me try again. So, hello, this is for me for the task number 3 of the project. So, this time we're working on some more stock prediction software, and this function I'm writing is an accept an area of the predicted price for a particular stock over the course of time, and you give me an example. So, uh, for this one, what is the goal? So our goal is we want to buy once and sell one, make the most money out of it. That's it. And first, you need a price example, just like this. And here, there's the examples for 10, 7, 5, 8, 11, 2, 6, whatever. And then it's like as we move on through the prices, and you have to always remember that the lowest price so far is the best day to buy. And each day ask, if I sell today, how much money do I make? Yeah, this is the important part. So to make this, you know what? I already, of course, make the headers and everything that is possible to make ourselves, like make our life easier. Okay. I don't think I should talk a lot about in this video because I feel like most of my things just goes pretty like too long. Okay. If I run it, yeah. I actually, if I'm being honest, in this one I didn't waste too much time on this one. So I actually did it everything and I actually tried to run it, which it actually worked. Was it took me more than I like expected. So I didn't like I forgot to make a video out of it. The most important part. So and this is like what I did, and I already get the maximum profit, which was it was a 7. And I think now I should just look at it and explain it. Oh, yeah, look. In the first word in our function header, and there's the int max profit, the const vector int the prices. So in this function, the name is named the max profit. And it returns to the integral, the max profit. It takes the list of prices called prices, and the const means we do not change the list. And then we have an empty checks. If there's no prices and you can buy or sell, the profit is zero. So we return to zero. And after that we have the low, oh my god. After that we have the lowest price int lowest price. So we start assuming that the first day is the cheapest and this store is the best price to buy so far. And then we get the best profit. Remember, when you start with zero profit, this keeps track of the highest profit found. Like I made little comment about that. It says the best price to buy and the maximum profit. And then we have a little loop through the prices for the end. That so let's say it starts at index one and it's the second day. So go through every remaining day. We check each prices a one. And then we have the profit if we sell today. Okay, let's just pretend this way that okay, let's just pretend this way. Bought bought at the lowest price, sell today. This gives a profit for today. And we had and then we had the if the current profit and the best profit, which is like the update, the best profit. Uh, so what does this mean is that if today's profit is better than before, save it as the new best profit. And just like that, you had to also upgrade the lowest uh, this profit, and the last thing is you just had to return to the best profit. Like you return the answer after checking all of the days is return to the maximum profit. Like let's just say it's like the code keeps track of the cheapest price to buy and check each day to sell if the selling that day gives more profit than before. So this is for the find and birth offer. Just like the devoker and some more stock predicted software your function you write accepts an area of the predicted prices of particular stocks over the, the course of time. And I feel like personally I feel like I did my job. So the job so I think it oh my god. It sh- it should be just that. And uh, I try to make everything so simple and quicker. So after all, you're gonna check a lot of students' video. So I don't want to make something like an hour long, but I just feel like because of all of this, it's going to be really, really long. But for this one, I try to make it shorter and easy to remember and try to explain my best to do the job. Thank you. Okay, hello. I just did the video stop like turning on my microphone. So we're gonna do it again. Oh shit. Okay, today we're gonna do the task number 4. We're writing a function that accepts an area of the number and computes the highest product of any of two number in an area. And at first glance it's easy so we can just assume to greatest number of the multiply them. However, our area can contain negative numbers and look like this. Okay, we're gonna use that. Okay? Okay, let's think about this. Because the area can have a negative numbers, the highest products can come from two big positive numbers or two really small negative numbers. Because why? Because the negative times negative is positive. The two largest not largest negative can give a really big positive product. So while scanning the area once, we track the largest number, the second largest number, and the smallest number, and the second smallest number. So let's put this back here and pull this down. Okay, the first thing is first, our example is 5, negative 10, negative 6, 9, and 4. Don't forget that. Okay, let's create a variables. Let's say int max1 equal to int min and max2 equal to int min and close it. And for the int min, no, sorry about that. I just made a little mistake. Thank God I catched it. It's a int max, int max. Good. So the in here the max one is the biggest number and max two is the second biggest number and the min one is the smaller number and the min two is the second smaller number. So we start them at extreme value. So any real number can be replaced them. That's pretty much it. So now we need a loop through the area or something like for int okay, like this, like this. Exactly. That's a good one. So last thing we had to do is to update the larger number. Like we had to show them just like it showed an example. We had to show them the uh for the update of the largest number. Okay, let's just yeah, just like the update the largest numbers, and it's gonna be something like if mm, max one max 2 will equal to max 1 and close it. License to be now we need an else. Yep. I love this. Else if and then max 2 equals to none. Okay, now we need an update for the smallest number. If the number the minimum is that, minimum is 2, minimum 2, min 1 equals to none, else if the 2 do exactly this. Yeah, so that was it. We just updated the larger number and the smaller number. Now we can compare the two possible products. We compare the product of the two largest number and the product of the two smallest number. Which is bigger, it's the answer. Got it? Just like that. We had to go and we need to return max. Max one. One. Okay. So if you walk through from there again, the maximum, let's just state it as a maximum 1 is equal to 9. So the max 2 equal to 5. Yeah, it's 5. And minimum 1 equal to -10. And minimum 2 equal to -6. So the product uh, will be equal to, yes, 9 times 5 equals to, and -10, which is 60. So, uh, so the answer is 60. Now we should be 60. Yep, I did it so many times, but I still had to do it again. I'm just gonna copy this and I'm just gonna post. Hello, so this is for the task. Actually, this is for the task number 5. And I'm almost finished, which is I'm really, really like glad about it. I'm so happy to finish with this. It was wonderful. Okay, for this task, like in this project, like we are designing a software to analyze the body temperature reading from the hundreds of human patients. This Okay, from what I just said, this has come from healthy individuals, and it's like a fall with near from like a 97 point degrees Fahrenheit to 99, like with the only one decimal place. Like an example said, it's here it is. Like I see it. Yeah. So our goal is to sort this reading from the lowest to highest. Again, just like I said, the normaling and the sorting number requires algorithm like a quick sort, which takes like an big O n log n time, where the n is the number that's reading. However, in this specific case, we can do better because the range of possible values are really limited. Since the temperature are only like a 97.0 to 99 and have only one decimal place, there are exactly few possible values. So the counting. So the how counting sort works. It's like the idea of counting sort is really simple. First, we can we we can count how many time to temperature occurs in an input list, then we can rebuild the sorting um, area. I mean, the main point is this is just again avoids the comparing numbers. So which it can be the slow down the sorting algorithm, but this one avoids it. And actually, we can do this pretty easily and quite simply. Just just like that, I've done the include lines and the nearing is with and the word. Wait, actually, why did I didn't do this easier? Where we had to put in the void sort temper. Oh my god, temperatures vector double. And so it's like a this function is the mm, sort the temperatures like a vector double in temps. Temps is the list of the numbers and that means the change of the original instead of the making a copy of it. So you can kind of say it that way. Like there's only values from 97 and to 99, and so the vector. Let me put this into int count to 21 to 0. Okay, now you had to. No, it's the auto is kind of making me confused when I was. And so what am I trying to do here is like rebuilding trying to rebuilding the sorted area, which is the j goes through all the possible temperature from 0 to 20 while the count j all in this part, it repeats as many as time as the temperature appears. No, this one's this because I did an outer. This is wrong. You had to do something like this. J plus 70. Because it's the converts the index back to the actual temperature. For example, mm, for example, mm, index 1 is uh 1 plus equal to 1 divided by equal to 97.0. Converts index back to temperature. Just like that, the move the, and by doing this, can move the next spot to the area. So next thing I had to do is just the main function. We can create the list of the temperature, call it like a sort temperature. It's like a sort of the list. And the loop through the sorted list is a print each numbers. It's gonna be something like the vector double temps, and we can put in our temperatures, and it would be nice. Just like that, we can start with an int main or main function and started it, and we can say vector double temp are equal to boom boom. What do we have here? No, it's too long. Oh my god. Okay. Let's see. 0.9. And wait, we did 99.9, and from this to this. And it's gonna make me do it. Temperature times for double count, and it's gonna turn our thing is. Okay. It's just for the return function, if you know what I meant. So when we finally ran the code, it's gonna count from the lowest to highest. This and this is what they are trying as makers do. Mm, you are right. It's a function that starts the lowest to highest, and when we okay, hello. So this is our task two, which is the last one, and the task two it's this. Oh my god, I finally did it. I feel so bad for it because I did it in the really last second. I didn't want to do it, to waited to finish this for so long, but it just happens to finish that way, and it's like almost 5 minutes away from actually a due time. I feel bad, but it's a task six. Okay, and this is pretty much the finding the longest consecutive sequence in area. Okay, let's read this. Actually, we're gonna just use the example. So, you're willing to writing a function that accepts an area unsorted integrates and returns to the length of the longest consecutive seconds amongst them. The sequence form the integral increase by one, for example. Ba 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 ba. The longest consecutive seconds is 2, 3, 4, 5. 2, 3, 4, 5. Oh yeah. This for integral from the increasing sequence because each integral is one greater than the previous one, while there is also sequence 10, 11, and 12. It's only sequence in the tree integral. In this case, the function should return to 4 length since the length of the longest consecutive seconds can be okay, so we just need the function that returns to 4 and 5. That's easy, right? Okay, what is the consecutive sequence? It's a set of numbers that increase is by 1, just like this. Mm, I mean, when you just look at it, you will think it's simple approach. Just let's use the nested loops, comparing every number with every other number to find the sequence. But we just talk about this so many times. This method is really slow because it requires checking each and every number. So we're not gonna do it. So my job is to optimize that it takes the big O and N. So it's a much faster approach to use a hash set to store all the numbers in the area as say as a data structure that allows us to quickly check of whether the number exists in it. Using the set, we can determine the constant number to whether the number is the present, which makes this algorithm faster. I guess it's really faster. So yeah, you find the rabbit. Good job. Okay, but this idea is to loop through each number in the area and to check it. It could be a start consecutive sequence. It's a number in the start the sequence. The number just before is number second one is enough in the end. Once the number is found. Okay, I calm down. Okay, because I already finished the coding. So I think I'm just gonna explain the code because I try to capture the moment of it, but it just didn't work that way because I took way longer than I expected. Like it took me a week to finish it, so I just couldn't stay there for 1 second and finish it all of at once. It was unexpected. Okay. So first we need the int the longest consecutive seconds. Okay, what it is means is that this is a function. It takes all the number calls and nums, and it returns an int, which is the length of the longest sequence. And then we had to create the set called a num set. And we can put all the numbers from the area into the set. A set let us quickly check if the numbers exist. Yeah? Yup. And format. It is pretty much that. I just got one of my tooth pulled out, so I'm sorry, it's my tooth. I just let one of my tooth got pulled out. So it's really hard time. Okay, that's good. I needed to pause for a minute because my pulled up tooth is bleeding. Alright, where was it? Oh yeah. We made the set, the num set. And then we did the for int nums. So we just like what this means is we can go to the each number in the area one by one. It's just that much. And then we had to check them. Oopsie. And then we had to check the negative one. It's like if it's not in the set. If it's not there, the num is start of the sequence. For example, if the num is equal to 2 and the 1 is not in the set, just start counting. If the number is 3 and 2 is in the set, skip. It's already part of the sequence. And then we had the current num. What it means is that it keeps moving forward in the sequence. Length counts how long the sequence it is. Like length. We start the length equal to 1 because the num itself is counts. That's why it says that the int length is equal to 1 because the num itself is counts. The count in the consecutive numbers though. So this is like as long as the next number exists in the set, keep going. It's just what it is. And then move to the next number, increase the sequence of the length. This. And if the sequence is longer than previous the best, save it to the new longest sequence.